All right, so this is topic 14, which is basic probability. And the description that it says, particularly on the review guide, is basic probability, including sample space, experimental and theoretical probability, and ways to determine theoretical probability. So before we go into a lot of these subcategories, I think it's definitely important to understand some definitions so you can interpret what everything means. So just in case anyone wants to look anything up, probability starts in the textbook on page 569. So that would be a good place to go in case you don't understand any of this and want to look for more example problems, because I specifically took ones that weren't examples. So all the worked out examples you can find in the book in case you need more clarification. To start with this though, experimental probability is the probability that is calculated when the actual situation is performed by an experiment. So during experimental probability, you will probably need to know what the number of trials is, which is the number of times the experiment has been repeated. The outcomes, which are different results possible for one trial of the experiment. And the frequency, which is the number of times that the outcome is observed. And especially with theoretical and experimental probability, it's important to know what sample space is, because that's how a person is able to portray what is mathematically likely to happen. So the sample space, which usually in most problems is represented with that U, it refers to all the possible outcomes of an experiment. And with that said, theoretical probability is the probability that is calculated using math formulas. So basically what this means is that the main difference between theoretical and experimental probability is that theoretical probability is what is most probable to happen based off of math theories and certain math formulas, while experimental probability is what actually happens in the experiment. So for example, if you have 3 red marbles in a bag and 2 green marbles in a bag, according to theoretical probability and math theories, you should be more likely to get the red marbles, to pick a red marble on a draw because there's 3 of them. However, experimentally, there is still a probability that you could get one of those 2 green marbles, even though you're not probable to get that. So, once again, one of the ways you can show theoretical and experimental probability is through sample space to show all the outcomes. Mainly with theoretical probability though. And the sample space can be shown through this one practice problem. Illustrate on a tree diagram the sample space for A, tossing a 5-cent and 10-cent coin simultaneously. So this right here, this chart is a tree diagram, which is a way that you're able to show the theoretical probability. And you can see when you toss a coin, a 5-cent coin, the chance of getting heads, and then there's the chance of getting tails, and then even if you get heads on the second time, or not the second time, but simultaneously when you throw the other coin, you can also get heads and tails. So it shows that even though one's 5 cents and the other's worth 10 cents, you still really have the same possibility with each one of getting heads or tails. And then for the second one, drawing 2 tickets from a hat containing a large quantity of pink, blue, and white tickets, this shows that draw 1, you can draw pink, blue, or white. And then draw 2, you can draw pink, blue, or white. Now, these are very simplistic tree diagrams. Normally, when you get a harder problem, you could even put in place of the P, blue, and B, and W. Well, not in place of it. You can still have it there if you want for easier reference, but you can also put the actual fraction, and you can use these to calculate fractions. So if the probability of getting pink has a 1/3, and the probability of getting a pink on the second round still is 1/3, then if you want to calculate the probability of getting a pink on 2 draws, you can just multiply 1/3 by 1/3. So theoretical probability, it's important to know going into an example problem that when you're calculating for a certain event or certain situation what might happen, you should use the formula probability of the A event equals the number of members of the event A over the total number of possible outcomes. So NA over NU, once again remembering that U represents all of the outcomes used for that sample space. So this is problem 1 on page 577. A marble is randomly selected from a box containing 5 green, 3 red, and 7 blue marbles. So to determine the probability that the marble is red, you have the number of red marbles over the sample space. So since there's 3 red marbles, the answer is 3 over 15, or 1/5. So you can do the same for B and C, which are still pretty simplistic, and then it gets a little harder with D when it asks for the probability that the marble is not red. So the probability that the marble is not red, what does this mean? Well, if it's not red, what other colors can the marble be? The marble can be green and it can be blue. So that's exactly what they're asking for. They want to know the number of green and blue marbles out of the entire sample space. So you take 5 out of 15 for green marbles plus 7 out of 15, which is the probability of getting a blue marble. And then you add it up and get 12/15, which can simplify down to 4/5. The same idea for D can be applied to E. They're asking for neither green nor blue. So what else could the marble be? They want you to find, once again, the probability of getting a red marble, which is, going back to A, 1/5. Hope that helps. Good luck on the midterm.